So welcome everybody. This is the third of the Digital Health and Informatics Networks industry breakfasts. Before we begin today, let me start by pressing some buttons on the thing. Okay. So before we begin today, I'd like to acknowledge the traditional owners of the lands on which we meet today, or the land on which we meet today. And we're meeting on the land of the Gadigal, and I'm paying my respects to elders past, present, and emerging. For those of you who haven't met me already, my name is Adam Dunn. I'm a professor of biomedical informatics here at the University of Sydney, and I lead biomedical informatics and digital health in the School of Medical Sciences. But here today, I'm in my capacity as the convener of the Digital Health and Informatics Network to welcome you to the industry breakfast. As I mentioned before, it's the third of ours, and I'm going to introduce you first to our first speaker, and then I'm going to ask questions of our esteemed panel following that. And then at 9 o'clock, we get to enjoy breakfast and a networking session. So today, I'm actually going to ask the panelists, and I don't hope they know this already, but I'm going to ask them to, when they introduce themselves, to give us a fun fact about themselves later in the panel sessions. So I figured to start them off, I'd give you my own fun fact. So I was reflecting that it was 20 years ago this year when I first started teaching algorithms to computer science students. And back then, when we learned about AI, it wasn't about trillions of parameters and transformers and data from all over the internet. I actually learned AI originally using a language called Prolog. And that programming language, I see some nods, which makes me a little bit happy. And that language was created about 50-something years ago. And it supported things like expert systems, but it also supported things like natural language processing, which I'm interested in. So if you haven't been to one of these industry breakfasts before, what you can expect is an opportunity to network with academics and industry leaders. And as a quick aside, the Digital Health and Informatics Network has over 1,000 members, and half of those members are academics, and half of those members are people from essentially the healthcare and tech industries, community, doctors, clinicians, people working in hospitals, those sorts of things. So it's a nice balance between academia and industry, which I really like. So today, we're going to be talking about artificial intelligence. We're going to specifically talk about how we can make use of AI safely, effectively, and responsibly in healthcare. So very shortly, we're going to hear an excellent introduction to the current issues. So I'm not going to spend too much time going through what I think the issues are in AI and in health. But I'm going to introduce you first to Malcolm Pradhan. So Malcolm is an adjunct professor of digital health here at the University of Sydney. He has been working in health informatics and AI for more than 30 years. This includes a medical degree originally at the University of Adelaide, after which he enrolled in a PhD in medical informatics at Stanford University, where he focused on how AI can handle uncertainty, evidence-based medicine, and incorporate patient preference for clinical decision-making and patient safety. In the early 2000s, he co-founded Alcidion Group, which was subsequently listed on the ASX. At his time at Alcidion, he worked as a chief medical officer with product teams in creating solutions for hospital patient flow, electronic medical records, results reporting, mobile apps, and virtual care. He left Alcidion last year. The fun fact, I think, or at least one of the things that he's written down here for me to say as part of his biography, is that he was also into AI before it was cool. So I think we're really going to enjoy this opening. Over to you, Malcolm.
Thank you. Thank you very much, Adam. So yes, look, I'm very excited to be here today and to be part of the panel with my esteemed colleagues. So I hope you've had your coffee. It's going to be a pretty rapid ride through some of the fundamental concepts around transformer networks in particular, which is really the technology behind the current excitement around AI and really trying to get the idea of what have they done to change AI. And hopefully some of those concepts that you see will be useful in discussing and thinking about this kind of technology and all the pressures you're going to be under to deploy this stuff. So traditionally, for a long time, we've had access, in terms of AI and analytics to numerical data, categorical data, and in about 2012, deep learning networks have been able to do image recognition really well, but not really integrated with those other modalities. But what's been invisible to us all along is clinical notes, so somewhat natural language. Clinical language is not that natural. Generation of text, but also query and synthesis. So a cardiologist today can't go up to a medical record and say, summarize the last 10 years of this patient's history for the cardiac history. They still have to page through notes like people have been doing for hundreds of years. And what's changed is that this transformer technology provides us with the first time we can get into that kind of data, because understanding that kind of information requires context, contextual knowledge, both from a clinical sense, but also just from a common sense kind of angle as well. So if you haven't played with ChatGPT in these areas, take your favorite condition and ask it to translate it into an analogy for someone with low healthcare literacy. And in this case, it's HDL to LDL ratio, and it comes up with good garbage trucks like HDL removing trash, the excess cholesterol, and bad garbage trucks dumping trash and causing streets to get blocked and causing heart problems. So it's fascinating how. So if people ask, can these things reason? Well, clearly they can, and they do. So transformer networks were first published in 2017 by Google, really for language translation. And as an unintended consequence of that technology, it was discovered that they actually learn facts from textual information. So large volumes of text go in, they try to predict the next word, and they start to learn facts, they abstract that out to concepts, and then they can reason about those facts and concepts. And all that's done automatically. So for decades, we've been manually linking pieces of information, trying to get computers to reason over it by writing code. And now this can just be done by giving them huge amounts of text. And transformers can be used in a couple of ways: a predictive way for classification, but the more popular one at the moment is generative, and might touch on some of those later. So how does predicting the next word lead to all this knowledge? It sounds kind of crazy. So you can put this, I went for a walk with my dog, but I stopped at a coffee shop because I had a pain in my blank, let's say. So a computer could choose any of these things or more, but and to us that looks silly because we have all this common sense knowledge that obviously you don't get a pain, and so that's what happens. The computer, when you're given it this task, these transform models start to generalize information and can reuse that information in new contexts that they haven't seen before. So they can understand that only living things can have pain, and maybe chest pain's more serious than leg pain. So, and coffee shops don't deliver healthcare yet. So, that's probably not where they're going to go. So it will say, yes, you stop at a coffee shop, it'll be pain most likely in the leg. But if you change that to hospital, it will change that and say, oh, it could be something more serious. So when we talk about transformers, these magical things that do all this stuff, we often talk about them in terms of their size in parameters, billions of parameters. And a parameter is a value or weight that is adjusted during training, as you're feeding it all this text, and it's predicting the next word, and it defines the model behavior. And a parameter, if you're familiar with, say, a stats package, you give it your study data, and it will then, like age, weight, etc. And the stats package learns the weights, for each of those inputs. So, you give it age 35, it multiplies it by the weight and all those other inputs. And that node at the end there, the risk prediction, just sums all that up and says, here's your risk prediction, right? And that's what the stats. So the transformers work in a similar way to that, except with billions of parameters. And instead of only taking in categorical and numerical values, say for logistic regression, that you can give it text, which include context that it hasn't seen before, it has not been trained on, but also instructions on how to deliver the answer. And the other term you may hear is tokens. It's just that words get split up into smaller pieces so that, you know, they can recognize words they may not have seen before. So let's walk through how a transformer works. So this is a foundation model that's been trained with, you know, billions or trillions of tokens or words. And it's got these layers, and those orange arcs and arrows are links or parameters, that the weights that have been learned. And that usually costs, oops, sorry. So look. Oh, there we go. And that usually costs millions of dollars to train, right? So ChatGPT or GPT-4 is probably around 100 million US dollars. But when we use them, we put in that prompt that include text, context, it activates those nodes, a bit like a regression model. The weights, the stronger weights fire off, the next layer adds those up, and if it hits a threshold, they propagate, and that gets through to the last layer, which just says, what's the most likely word that I need to output? And then it rotates around that. That's it. Now, if we're trying to specialize it for a task, these things cost a lot of money to train. So what we can do is, rather than retrain everything, we can add a couple of, some fine-tuning layers that can influence the behavior of the model by only, you know, by modifying the model for specific tasks at a much cheaper sort of rate. Rather than retraining everything. So you'll hear, so GPT-3 and 4, for example, are foundation models, and ChatGPT is a fine-tuned model, and most of the models we'll deal with are fine-tuned. But they all suffer the same kind of issues. During that propagation through the network, they may go through erroneous paths, which can cause hallucination, or just things that sound plausible but are completely made up. We don't track the sources, the provenance of the data, so we don't know what's high quality data versus not high quality data. They don't express uncertainty. They are descriptive systems, so they're built on text and data that are current practice, which we know have issues with fairness and bias. And the knowledge there isn't, you can't just point to a bunch of nodes and weights and say that's where renal function and that's where antibiotic resistance is understood. The knowledge is distributed, so they're essentially black boxes. So the early models, like BERT and its family of transformers by Google, were really designed for search, as you'd expect from Google. OpenAI then really lent into the generative side. And so the size of those bubbles is the size in billions of parameters of these models. 2 days ago, it was revealed that GPT-4 is about 1.7 trillion parameters. And so in February this year, if you want to do anything with transformers, and there were a whole bunch of talks saying, look, you've got to go to OpenAI and to Google to do this stuff. And what happened in March was that Meta, or Facebook, released Llama. Well, it kind of got leaked into the open source community. And that has allowed a whole lot of universities and researchers and companies to now start innovating on transformer technology that they want to run locally outside of the big corporations. So the two key events here are ChatGPT, which was first allowed us to interact in a realistic way with the knowledge inside of the model. And the other one really is Llama, which has spurred this incredible degree of innovation in transformer technology. Like every other day, literally, there is some breakthrough going on in this area. So that's just taken off like crazy. And if you look at this, so Llama originally, when it was released, didn't perform that well, say, against ChatGPT, which is that one over there. But 11 weeks later, Orca, which is another variant, because they ran out of, llama names at some point, like alpaca and vicuna and dromedary or whatever. So Orca, you can see, has now exceeded in specialized areas. And what that means is that companies and researchers can create specialized, smaller models embedded into bits of software, rather than which can run locally, rather than having to rely on companies like OpenAI and Google. So in summary, and I'm really shocked that I've kept to time, so pardon me, that's why I'm sort of little bit stunned. That never happens. So clinical care is inherently based in language. So there are clearly many potential uses for this technology in healthcare, and it's really exciting. However, there are some really key problems which we'll discuss next that need to be solved. And the pressure that we're all going to be under is that there's so much investment going on into this area, and it's really easy to get a demo up that looks kind of cool. And so there's a whole lot of applications that are coming to market, or at least demoable to clinicians that may not be clinically appropriate. So hopefully that's given you a bit of a mental model of what these things are, and hopefully that's been useful. Thank you.
All right. We're now up to the Q&A section. Don't mind me while I just, I'll put this slide up for now, and we'll leave it up for the session as well. But hopefully Isabel will come and change it to the video in a minute while I continue to introduce people. So first, thanks Malcolm for the excellent introduction. I now know more than I knew 10 minutes ago.
That's good.
Which is good, yeah. So we now have 3 additional panel members to introduce, and the way this is going to work is that we're going to get them to sort of introduce themselves, and I'm going to ping them to answer a fun fact, but I'm going to also ask them a question. So they're going to take 5 or so minutes to introduce themselves and answer a specific question one by one. So we won't get all the introductions right at the start, but let me start by just briefly introducing them. So Alex Wagstaff is the current Chief Information Officer at Sydney Local Health District. Farah Maghrabi is Professor of Biomedical and Health Informatics at the Centre for Health Informatics at the Australian Institute of Health Innovation, also my first boss in Sydney. And Ben Hashi is our Beamtree Associate Professor of Clinical Informatics and Data Science here in the Faculty of Medicine and Health at the University of Sydney. Okay, so we've got our 4 panelists here, and we're going to introduce the other 3 one by one. And the first person I'm going to ask to answer a question is Alex. So let's start with the use of AI in our hospitals and local health districts. So can I ask you to firstly introduce yourself, maybe with a fun fact if you want, and then to consider the following. We've seen recent news articles reporting that we might see increasing regulation and potentially even bans on the use of certain high-risk AI. Are there any places where AI can be used responsibly in healthcare delivery?
Great, thanks, Adam. Look, fun facts about me. I've worked in the public health sector for over 20 years now. My very first job I walked into as a 21-year-old as a receptionist in what was a drug and alcohol clinic, and walked in after studying into what I thought was going to be a transformative dynamic. We're in health, we've got technology, and it was paper. Everything was paper, from writing down a patient's name, we'd collect all the information, then I'd go from one desk to another desk, enter that into a computer, then I'd print it out to put it into a file, because that was how everything worked. It was totally paper. So interesting experience, and watching the next 25 years of health and how it's transformed has been a fantastic experience. But it was a very eye-opening experience stepping in the front door of a public health service 25 years ago. So to your question, I think it's an interesting question because AI is the buzzword, and throughout healthcare, it is constant. Every day the questions: when are we using AI? How are we using it? How's it going to improve healthcare? But there's an enormous risk. It's unknown in healthcare. I mean, healthcare is based on research evidence. We treat patients based upon what we predict the outcomes are going to be from evidence. At the moment with AI and where it's sitting in the technology, we don't know where that information is coming from. It's giving us a great answer. It sounds really good. It sounds intelligent. It sounds like it's right. But is it? We actually don't know. So from a healthcare perspective, there is an investment that we need to make. At the moment, the policies, those guardrails that we work with in healthcare is not there in AI. We're doing it in small pockets of research, and that's great, where we're able to prove, within a contained environment, because it's a trusted environment. We know where that data's come from. We know what the AI is interpreting is trusted evidence. In terms of the large scale, it's a big risk for healthcare right now. We know people are using it, and it's concerning. It's something we're looking at from a policy perspective in terms of how we can actually enforce its use or not using it. Do I think there's ways in which we could use AI right now in healthcare? Absolutely. But I think we need, the lower risk areas are more of a corporate-based area in terms of looking at, if you are a clinician, the hundreds and hundreds of policies and protocols and guidelines that you need to be aware of is enormous, and it's time consuming. So I think that is definitely an area for AI from a corporate perspective, where we could actually enhance our clinical services by providing information, but from a trusted source. That's the investment we need to make in healthcare, is actually ensuring that where we are using AI, we actually know where the AI is obtaining that information from and controlling that source.
Mm-hmm.
So I think that, there are massive efficiencies we could gain across the health system from using AI in those more lower risk areas where we can contain those sources.
Yeah, fantastic. Makes me wonder a little bit about what it looks like to robustly generate real world evidence of where AI is being used in an intervention or in other ways as well. Okay, let's move on to our next person, which is Farah. So Farah, will you please introduce yourself briefly, hopefully with a little fun fact if you like. And then my question for you is, how often do things actually go wrong when we introduce AI or other tech in healthcare? Are we worried about something that doesn't happen that often, is rare, has limited impact?
Cool, thanks, Adam. And thanks for having me. So essentially, look, I lead a team in AI system safety at Macquarie University. My background, I trained as an engineer in biomedical engineering and electrical engineering before I moved to health. And really, the fun fact about me is that, picking up on the 20-year theme that both Alex and Adam have kind of touched on, my undergrad thesis was in machine vision. I was doing expert systems with Prolog and ripple down rules as part of my PhD, and telehealth as well. And it's taken a pandemic for telehealth to become mainstream, and ChatGPT for AI to become mainstream. So really, it's I feel my time has come. In terms of safety of these systems, look, I think it's important to sort of start off by saying, and really, emphasizing kind of what Alex has already sort of touched on, in the sense that these technologies have enormous potential to solve, some of the intractable problems that we are trying to solve in healthcare. But like any other tech, I mean, look, we hopefully design and implement these systems with a specific purpose, but they do have unintended consequences. And especially with IT systems, more often than not, they do have unintended consequences. When we're talking about AI, I think it's important to sort of distinguish the clinical grade systems that are subject to medical device regulation in Australia. So if you're using any kind of AI, whether it's machine learning, or generative AI, it is subject to medical device regulation if you're using it for diagnosis and treatment. And the TGA has kind of sort of emphasized that again for the generative AI. Sort of don't forget that just because it might be generative, that it's not subject to medical device regulation. So coming back to kind of the clinical grade systems, the research that we've done, especially we've trolled through FDA data for the last 6 years. And we do find that, look, when these systems don't work as they are intended, or they fail. So I'm using a machine learning system to assist a doctor to detect blockages from a CT, whether it fails or it fails to correctly detect that blockage, the location of that blockage, well, it's actually going to increase the risks that patients would be harmed because these systems are not 100% accurate. So it puts the onus back on the doctor in some ways. The second area, which is probably the more important area, is where these systems don't really are hard to learn and use. They don't fit our kind of, ways of working, and that those are the human factors issues. And so in the data that we've looked at, essentially what we have found is when there is a breakdown in that human computer interface, patients are more likely to be harmed. And so in the incidents that involved patient harm, we found that human factors issues were proportionally higher. So we do need to take, these risks seriously. We need to make sure that even if we're introducing systems into our clinical workflows, that they actually fit that workflow. They don't make things more difficult for clinicians.
Fantastic. So I guess the interesting thing there is it's not necessarily the algorithms or the models that are wrong. They might perform quite adequately in simulated, in static data, but when we introduce them into the workflow, that's where the problems start to really appear, which is really interesting. Okay, Ben, will you please introduce yourself again? If you have a fun fact, that'd be good. And then my question for you is, what do you see the greatest gains in health outcomes from AI in the next 5 to 10 years? What should we be working on in research now to be ready for that?
Thank you. Thanks. Great question. So as Adam mentioned, I'm currently a Beamtree Associate Professor of Clinical Informatics and Data Science at University of Sydney. I like to think of myself as an AI and data science practitioner and focus on design and evaluation of AI assist tools. So it's a bit of a theme, I feel like, that's developing here. During COVID, I spent most of COVID and a bit more at Harrison AI, where I built the AI engineering and AI platform teams and helped to deliver AI and the Annalise AI assist tools for radiology. In terms of fun fact, I'm going to testify that I'm a recent convert to health and medical sciences. While I trained my first small language model 20 years ago on biomedical text, for a long time, I think I was a computer scientist wandering in the darkness with a hammer in search of nails. But my revelation, I think, came 7 years ago in the first startup that I was involved with, where which really flipped my thinking, I think, and to really a more human-centered design kind of approach and real focus on interfaces and integration with workflow. And now I believe that that healthcare is the best place to be doing AI. I think it's compelling and beneficial, but also I think we have a real opportunity to drive best practice in applied AI and build an evidence base for effective use. And maybe if that wasn't quite in the spirit of the question, I read too much Jack Kerouac when I was a teenager, and I dropped out of high school and I rode freight trains across the US, but maybe that's a conversation for another time. So in terms of the question, so I think, yeah, two real key areas where I think we have evidence growing that AI can really provide gains. And those two areas are quality and productivity. And there's, I think, two studies that I'd like to just really briefly touch on. So the first is from Annalise. So at Annalise, as part of getting our product onto market, we did an evaluation where we're looking at radiologist accuracy with and without an AI assistant. And in the publication the first validation study that we did, which is in Lancet Digital Health, we looked at the radiologist accuracy across 124 different chest X-ray findings. And the sort of headline result there is that it increased radiologist accuracy when they were using the tool in 80% of those findings without a decrease in other findings. The second study is a more recent one that comes from Stanford. It's a bit more of like an economic study, and it's not in healthcare, it's in customer support. But I think it's the first, I believe it's the first and only real world evaluation of a language model enabled AI tool. So it's a customer support assistant. Customer support agents are working, helping customers through a chat interface. The tool suggests a possible response based on the history of the conversation, and also tries to retrieve something from the knowledge base that's relevant to that conversation that the agent on to the customer. And this is a bit of a pattern, I think, that's emerging as well for using large language models effectively. But the headline result here is a 14% increase in productivity. Well, that's lower than some of the hype that you see about productivity, potential productivity increases from the current generation of AI. It's material. I think I would take 14% any day. I'd take less than 14%. Other endpoints from that study show improved customer sentiment and better employee retention. And one of the really interesting things when you dig down is the impact is imbalanced. So the impact is much higher for less experienced and new workers. There's a 30% increase in productivity. So I think this is interesting because it suggests there's a knowledge sharing effect, and it should suggest that it can help with onboarding new employees, help them to become productive more quickly, and possibly even that they're sort of opening up a new employee segment, right? Where with these tools, different people or people with different skill sets might be able to do parts of these jobs. Again, I think it takes really, really careful design of how you build these things to integrate with workflow and allocate tasks between human expertise and AI expertise. But I think the early evidence is really exciting. So this is where I think we should be focusing is designing and evaluating these kinds of AI assist tools. And again, like I think we have an opportunity to really consolidate best practice for AI evaluation.
Fantastic. You know, it makes me, the knowledge sharing idea and the benefit to the newest in people makes me think about the use of AI, or at least machine learning methods, in the standardization of clinical decision making, and the potential to reduce unwarranted variations of care, which is a really interesting idea. So I'm going to open up questions to the whole panel, but I'm going to start with Malcolm. I don't know whether I'll ask you the question I was thinking of asking you. I was considering whether or not I'd trick you and ask a completely different question. But
thank you.
But Malcolm, so I guess if these large language models and their interfaces are now easy for just about anybody to access at any point in time, but they don't tell us where they get their information from. They can hallucinate, and they don't tell us about uncertainty. Where do we go? Like, what can we use them safely in healthcare eventually?
I think there's so much work going on at the moment to try to manage the hallucination thing in particular, because they can be very convincing when they go and make up stuff. It's not, always completely random. So they get things almost right, or they make things up that are plausible, which is the risky part. However, I think there's a number of ways of using that, and I alluded to that earlier when there's a paper just I think last week from New York University, where they used a transformer model, one of the earlier BERT non-generative ones, for risk prediction in hospitals, to be able to incorporate on clinical notes and other things like that. So there are ways of using it as a prediction model rather than a generative model, which may improve, because we're incorporating a whole lot of text and other information, and you can also integrate images into these models as well, other modalities. So I think there are ways of using them perhaps a little more safely in that aspect, and that can be tested as any other prediction model. The other aspect is that we can also use them to detect features and put them into explainable models. So for example, if there's a model that says the risk of something is increased if you've got, say, a family history of heart disease or say breast cancer, that's actually quite hard to find because of the way clinical notes are just splat out, right? You don't always have a nice section with family history or whatever. And language models are really good at that nuanced, detection of those features, which can then So you can do feature extraction and put them into an explainable, model as well. So those are sort of more immediate ways of using those kinds of models, which is a big improvement over what we have already. But the explainability and the black box nature just means the amount of testing involved. And one of the issues is that you've got, say, OpenAI and Google innovating and changing the models underneath, as well. And so something that's validated today, there might be a new version pushed out because they've picked up some, terrible racial slurs it's doing somewhere. And you don't know how that repairing that thing over there is going to affect all the other behavior. So there is this issue of, treating it like any standard intervention in healthcare where it needs to be validated and tested and so forth. So there are, I think, some safe ways of using it, which are a big improvement over what we have, but they're not necessarily the sexiest ways that, people are demoing out immediately, which are, I think, more risky and require a lot more work.
Any other thoughts from the rest of the panel? And while they're thinking about their potential answers to that one, I'll let you know that next I'll ask the audience if they have any questions. So think about your next question as we throw to the rest of the panel.
Maybe I'll kind of just respond a little bit to that, and then it's probably a question for Malcolm here, where so these generative models, they've kind of been described as sort of stochastic parrots in some ways, and then there's companies now claiming that, look, you can train it on this data, so it's singing from your song sheet. How far is that believable?
Yeah, so there was a really interesting paper. As I said, this stuff's happening so quickly. Yesterday, from Microsoft, which trained a 1.3 billion parameter model, so tiny model on a very specific task, and came up with really best of, sort of state-of-the-art performance on that particular task. And that was generating programming. So it's not a trivial task. So you can get very good performance, but what they also found was that it was more prone to hallucination, or what's called out of distribution inputs and outputs. So in some ways, these models almost need like another system to be a chaperone for them, like adult supervision, both on the inputs and the outputs. So I think that there is absolutely, just looking at the headline numbers saying, yeah, you can get very focused models that perform really well, but their behavior again is a little bit more unpredictable in certain cases. So there's always a trade-off. But I think the idea that there may be multiple different models working and checking each other. So you might have less accurate or less predictive models that are more reliable and that can manage uncertainty, a so-called mixture of experts sort of approach, where you have multiple models working, and if the safe one sort of agrees with the young, crazy, more accurate one, that when it's right, it's really does well, but when it's not, it can be picked up. So there are methods that can be used in this kind of use. But again, I haven't heard of many discussions going on. It's just a race to market at the moment.
So I'll get everybody to put up your hand if you'd like to ask a question. But while you're doing that and the microphone is racing around to you, I can see a couple there. Here, and here. Alex, I wanted to ask you a quick one. So you're hearing about, all these new opportunities and new technologies and new things that could be done. How do you make a decision about which ones are allowed to be tested or used in a clinical space?
Look, I think with anything that we do in healthcare, we have to look at it from the perspectives of, what are the benefits for our clinicians and treating of our patients. We do need to look at our return on investment in it as well, but it is very much clinically driven. Are we going to see benefits in the treatment of our patients? And it's really going through that prioritization with our clinical services in understanding, well, what are the benefits that we're going to see out of implementing this product? Are we going to see that suddenly we're now actually able to, reduce our diagnosis timeframes from, something that potentially at the moment might take us, 7 to 10 days to actually be able to get a result, that we're actually now cutting that down to, less than 3 days. So, I think, we have to look at that bigger picture of what implementing this AI, what are the outcomes that it's actually going to be giving to us. So yeah, that would be some of the things that we'd look at.
And it must be hard if there's no real world evidence to support the claims that are being made about how much time can be reduced. So we have to work out which comes first of those two. Question over here, I think first. Yep.
Hi,
Can
Karen
you
Luxford.
say your name as well? And
Hi. Karen Luxford, CEO of the Australian Council on Healthcare Standards. Thanks very much for a great session. Just a question to Malcolm. I thought your diagram really clearly illustrated that the quality of the outputs are only as good as the quality of the inputs. And so what do you think that means, Malcolm, for critical thinking and critiquing, particularly in the healthcare sector, because we know the information is being pulled from a range of different sources?
Yes, I think that's really that issue's come up, and that small model that was high performing was achieved because they focused on very high quality information going into that model, and I think as Ben was saying, the model that has been quite well established over the last few years, particularly in the image space, is that augmentation is a very it provides big benefits. And I think that kind of augmentation model where the responsibility is still with the clinician, but they're able to bring salient information together with a smart assistant, if you like. So we're reducing just the legwork of these tasks, because clinicians have so much cognitive burden and so much time pressure, they don't really get time for that critical thinking often. And so if we can make time available to allow clinicians to be able to have that information, they're not paging through huge amounts of information all the time. So I think there's a really good augmentation story there potentially, but again, there's still some work because some of those facts can just be made up sometimes. But I think the real opportunity is to try to get that augmentation model working so that clinicians are actually working at the top of their game into the really hard problems, rather than the kind of manual stuff that clinicians are sort of expected to do, but really aren't adding value, hunting down information and running around doing manual tasks.
I think we have a question over here, but as we're moving over there and before you start, quick one, Ben, how do you implement guardrails so that people who are experts in their fields can sort of wrap around these models and keep us safe?
Good question, and I did want to touch on actually the part of your previous question to Malcolm, which is about accessibility, which is I think really interesting, right? So the fact that we have sort of freely available chat interfaces to these models, I think is one of the things that's a really big change, and one of the impacts is that everybody's having to play with it. But it's also one of the challenges, right? Because it means that it's really easy to go off-label. Not that there is an on-label use, but it's really easy to go off-label and really easy to use them in a way that's sort of not living up to our standards for privacy and safety. And I think there's a really interesting recent example of this, another case study, which is the ChatGPT lawyer in New York, right? Who from the testimony that he's since given, completely misunderstood the capabilities and limitations, filed a brief that came directly from ChatGPT. It was full of fake judicial opinions and fake legal references, and he's now possibly might end up being sanctioned. And I think this is a nice illustration of the fact that we need more better documentation and training in how to use these tools. But also I think going back to the theme that we've had here, which is I think careful design of AI assist tools that augment human intelligence is really important.
For sure. And just the other day, I marked my first example of someone who used ChatGPT for an exam or an assessment and summarized entirely the wrong paper. Question over there.
Hi, yeah, thanks so much, Dr. Lisa Sharwood, AHW and UNSW. So as a former critical care nurse in the ED, morphed into an epidemiologist and emerging health data scientist, I'm interested in picking up what you talked about, Ben, using their customer service and employee retention, given particularly since COVID, we've seen massive frontline worker burnout, et cetera. How do you see AI being able to help retain staff, because that's one of the main problems in healthcare, in addition to helping patients.
Yeah, well, exactly. I think this particular study is really, really interesting. So I think if we can find those kinds of workflows where we can sit down and design tools that help with that knowledge sharing and help with streamlining that process. I think maybe one example is clinical coding, right? Where there's definitely a shortage of workers, and I think definitely we can design tools that improve that workflow and augment people doing that workflow. I'm also really interested in, I guess, virtual care, I think, is another place where, again, we sort of have the digital infrastructure to be able to design interventions like this that could be good assistive technologies. Telephone lines, another one. Yeah, I don't know. I think this is a real opportunity, and this is what, like, collectively we have the opportunity to do now, is go out and identify these use cases and explore and design good AI assist tools. Thank you.
One more question over here somewhere. Yep.
Hi, Mark Ryan, technology consultant. Real world question to the panel with respect to the My Health record. It has got millions and millions of records with respect to medications that are stored by the federal government. Does the panel see AI helping in, for example, medication management with a My Health record?
Yeah.
Look, I think that's probably something that we're looking at in terms of that high risk AI. Are we there yet? I don't think we are yet in the health system. When we look at what we can make available here and now, I think we're really looking at our evidence-based use of AI is probably more based from where we can gain the efficiencies, as we've just been discussing, around how we can enhance our workforce and we can provide those efficiencies, because the risk there, we're not utilizing AI to make diagnoses decisions, to actually inform our clinicians on making those clinical decisions. We're utilizing that more corporate data to enhance the services, to provide the knowledge base to our clinicians based on our contained evidence that we have. Look, are we looking at that from a local health district perspective at the moment? No, that's not where our investment is at the moment. I think it's a question that we need to be looking at across, our state and our federal systems, in terms of what are we going to be utilizing AI for across those various different systems. But I'd say at the moment, that's something we need to look at from more trusted sources of information.
Yeah, look, I think there is some low-hanging fruit there before jumping straight into, say, some of these other areas. So even just indexing and semantic search. So imagine if a GP is sitting there and entering some data, and the system says, oh, look, there's something that's relevant, that's worthy of your click, because as I've said for many years, every click or tap with the clinician is pushing a friendship, right? So if you say, oh, there's something in the record, in the My Health record, that's relevant that you don't know about, that's not in your record, so there are these little things that can be done just even using, say, the semantic search aspects of language models before we jump into the generative side, that are really about improving workflows and targeting safety. Because there's as you said, Alex, like just indexing and being able to retrieve contextual information. But then the game, as we've been talking about, and Farah mentioned earlier, is about reducing variation, improving safety, and value-based care in terms of, compliance and how do you safely implement new models of care. That's the game. And there are a lot of shiny distractions around. So it's useful to think about how we're going to use these tools to, for those kinds of goals that are really important, as well as obviously the equity issues.
Fantastic. And just a reminder that you'll have plenty more opportunities to ask the panel and other people questions at the end over breakfast. But we've got one more question over this side.
Oh, hi. Eduardo Delamere. I'm a lecturer at UCID, Medicine and Health, and PhD candidate. I have a question for Malcolm. In these open source models that you mentioned, and being privacy issues one of the main concerns that we have in researching AI in healthcare, do you see any potential for these open source systems to be used in an offline and therefore more private environment? And also adding to that, do you feel that there's potential for these open source systems to, because of this deployment in a more personalized way, to be used in this mixture of experts or ensemble models?
Yeah, absolutely. That's what's exciting to me about all this progress, is that it allows, you're not then sending data out to the US or other models, even though Microsoft, I think, are creating local instances of GPT, but still you can control where that data goes from a privacy perspective. And I think the attraction of the local models or the smaller open source models is that, as we were discussing before, they're a lot more targeted. And so, there might be a number of different models working to solve specific sorts of problems, like detecting certain features or analyzing protocols or whatever. So I think that's really exciting. And the fact that you can test the software and validate it and go through all the regulatory side of things and release it as a validated package of software, rather than something that might be shifting on a service-oriented approach, which is great from a consumer point of view, for general consumers. But in the healthcare industry, you need to be able to validate that version, and have all the appropriate audit trail of all of that stuff from a regulatory point of view. So I think that's what's exciting to me, is I think the chat stuff is very cool and lots of demos can be made, but actually when you think about how do we implement them in the real world, I think the smaller models are really interesting.
Fantastic. So I'm going to use my prerogative as host to give the last thoughts to Farah, and the reason why is because Farah's the reason. I've told her this many times. She probably gets embarrassed every time I say it. Farah's the reason I'm here and I'm doing health informatics in the first place. So I thought we'd wrap up with some final thoughts from Farah.
Thanks, Adam. And kind of to get you back on that, essentially, Adam, we recruited him all the way from Perth, and he rings me up and says, right, I'm driving across the Nullarbor. And I'm like, oh my goodness, I hope he makes it. It's one of the first docs I've recruited. He better make it, because I'm not going to look good otherwise. So he's here, he arrived and he thrived, and here he is. So look, but final thoughts in AI, it's a really exciting time. And in Australia, in some ways, we're sort of playing catch up to the rest of the world in terms of waking up to these technologies, investing in them, especially with research and our health dollars. There's a consultation that is out from Ed Husick's office at the moment. So, by all means, try to respond to that if you can. There's also work that is happening as part of the Australian Alliance for AI in Healthcare. We sort of have a consultation again opened up at the moment, kind of really trying, we put together a roadmap about 2 years ago. So the roadmap is already there. It's about, we're sort of trying to refresh it now and sort of take it to Canberra. So if you're interested in that, please come and chat with me. And so it's really kind of up to us that if we want this, technology deployed in our health services and deployed safely and responsibly, we need to be kind of out there and kind of advocating for it as well, and advocating for the dollars that need to go with it. And so, come and chat with me if you're interested. And sort of final plug is for the study that we're doing at Sydney LHD evaluating the Annalise AI chest X-ray system. So if you're an ED doctor, come and see me. Thanks very much.
Fantastic. All right. Thank you, everybody. Well done. So let me thank you all for your questions and for engaging in this conversation. Before we let you disperse and go and have breakfast, I just wanted to remind you of a few little things. So first, if you're not already signed up to the Digital Health and Informatics Network, please do. I expect everyone here is, since this is the event and this is probably how you found out about it. Second, this breakfast is also kind of a launch for our newest special interest group, which is going to be focused on AI. This one, good. And so we'll have more related to this on the Digital Health and Informatics Network website soon. I've been promising that we're going to update the Digital Health and Informatics Network website for a little while now, a couple of years, and we're going to try and make that happen as quickly as possible. It's getting there. It's nearly done. Isabel, thank you. So in the meantime, I think it's a LinkedIn group that you can join and engage with and connect with other people, including Malcolm and Ben and others. And then my next one is this one. Click. Okay, good. So third one is that we'll be launching a new digital health short course that's focused on AI in October. So you might be interested in learning more about AI yourself or sending your colleagues to learn about AI. So please see the information here, or you can talk to Anna Jansen, who's in the back there. Thank you very much. Very good. And then finally, the last one I wanted to talk about was that the University of Sydney has a Master of Digital Health and Data Science course program, which includes units that teach about AI. And a feature of this particular course is its industry capstones. So this is something that you or your colleagues might be interested in joining and taking as a master's, or alternatively, you might be interested as an industry partner in supporting some of the capstone students who are probably likely to be your future employees, we would hope. So that's the Master of Digital Health and Data Science. So thank you very much. All right. So last but not least, thank you to Isabel and the whole FMH Networks team. Look, she's shy, but runs these things amazingly well every single time. As you can see, we are always fully registered within a week for these industry breakfasts. They're extremely popular. And that's mostly because Isabel does such a damn good job. Thank you very much. So thank you, everybody. And that's it. Thank you. And please join us for breakfast and coffee and whatever else you like, and come and chat to us. We're more than happy to hang around and answer questions. Thank you, everybody.